Hi class, going over NQ number 2 for unit 7. This is the energy unit. The problem is asking us to do number 48 and 49 on page 320. Now I noticed in order to do these problems you need to know the specific heat of water, which is 4.184 joules per gram degree Celsius, and you're actually going to need to know the specific heat of silver. Those values are given to you on page 297, and the specific heat of silver is 0.24 joules per gram degree Celsius. You're going to need silver for problem 49, and you're going to need water for problem 48. Before we begin, let's talk about this. Since silver requires less joules or less energy to raise 1 gram of it 1 degree Celsius, silver is easier to heat up. All right, well, we're using an equation here. So we're going to call our boy Eric P in. If you guys follow along with me on problem 48, it says calculate the amount of energy required to heat 140 grams of water from 22.3 degrees Celsius to 75 degrees Celsius. So our equation, energy equals mc delta T. Rearrange it. We don't have to because we're solving for energy. We're heating up water, so, well, let's plug in the values first. M. They gave us M, and M was 145 grams. Here with the equation, we rearranged it. Do we need to crisscross this? We do not, because mass is supposed to be in grams. So we are fine there. C, specific heat of water, 4.184 joules per gram degree Celsius. We do not need to do anything with that as well. 4.184 joules per gram degree Celsius is the correct unit for specific heat. So we are fine. Let's simply find delta T, or change in T, just T final minus T initial, and they gave us the value. It was heated to 75 degrees Celsius, and it began at 22.3 degrees Celsius. So I'm going to push this into my ghetto superstar. 75 minus 22.3 is going to be equal to 52.7. Okay, so we have our mass, we have our C, we have our delta T. So we're going to plug them into our equation. Energy equals 145 grams multiplied by 4.184 joules gram degree Celsius, grams cancel, multiplied by 52.7 degrees Celsius, degrees Celsius cancel, we end up with the unit we want, that is joules. So 145 multiplied by 4.184 multiplied by 52.7 gives me, wow, 31,972 joules. But they ask for the answer in calories. So we're going to have to do a quick crisscross here. 31,972 joules. We're going to crisscross it to calories. If you go up to the conversion factor that I gave you, there is 4.184 joules in every 1 calorie. So 4.184 joules in every 1 calorie. This number 31972 divided by 4.184 equals 7,641. 7,641 calories. A little bit easier number to work with. Going on to problem 48. Problem 48, I'm going to make a line under here so it's a little easier to see. Problem 48 asks us, actually problem 49, hold on here. What did I do? We're doing 48 and 49, and I wrote 48 and 48. Typical Mr. Musalam blunder. Problem 49 asks us, it takes 1.25 kilojoules of energy to heat a sample of pure silver from 12 degrees Celsius to 15.2 degrees Celsius. Calculate the mass. Okay. Equation. Our energy equals mc delta T. Rearrange it, because we're solving for mass. Mass equals energy divided by C delta T. Divided both sides by the C delta T to get it over there. Crisscross. In this case, we're solving for energy first. They gave us 1.25 kilojoules. That's not in the correct unit. We want it in joules. So we're going to go up to the conversion factor that I gave you right here. And we're going to crisscross, and every 1 kilojoule we have 1,000 joules. That's going to be 1,250 joules. So we have E. C, I told you, is going to be 0.20 joules gram degrees Celsius, because we are talking about silver, or Ag, that's silver. That's in the correct unit, so we don't need to do anything there. Delta T is going to be T final minus T initial. 15.2 degrees Celsius minus our initial temperature of 12 degrees Celsius. We're going to have a difference of 3.2 degrees Celsius. Let's go plug it back in to our initial equation. Alright, energy over C delta T came from up there. Mass equals 1,250 joules divided by 0.20 joules gram degrees Celsius, which is going to be multiplied by 3.2 degrees Celsius. Joules is going to cancel there, and degrees Celsius is going to cancel there, and we end up with our unit of grams. So 0.2, this is going to be 1250 divided by 0.2 times 3.2, which is 0.64, equals 1,953. 1,953 grams, and they said just calculate the mass, so we're going to assume we can keep it in grams. If you converted that to kilograms, you get 1.953 kilograms. Okay, take care guys, and I'll talk to you later. Enjoy your night.